All right, let's talk about something that's becoming absolutely critical: data integrity for AI, especially in regulated fields. When an AI is involved in things like manufacturing or medicine, trust isn't just some nice-to-have feature, it's the bedrock of the entire system.
And it all boils down to this one simple, powerful idea. You could have the most brilliant algorithm on the planet, but if you feed it garbage data, well, you're going to get garbage out. So trust in the AI really starts with trust in its data.
Now, here's where it gets tricky. In these high-stakes environments, you can't just say your system is reliable, you have to prove it. That means you have to design the system from the ground up so that it can be verified, audited, and defended. Trust has to be demonstrated.
So, how in the world do you build and demonstrate that kind of trust? It comes down to what we're calling the pillars of provenance. And this all starts with two key concepts we need to get our heads around: data integrity and data provenance. Let's break those down.
Okay, first up, data integrity. What does that even mean? Well, simply put, it's the guarantee that your data is exactly what you think it is. It's complete, it's accurate, and it hasn't been messed with at any point. Not the source data, not the context you give it, not the final output.
The second pillar is data provenance. Think of this like the data's autobiography, or its chain of custody. If integrity tells you the data is what it should be, provenance tells you its entire life story, where it came from, every stop it made, and everything that happened to it along the way.
And look, when we talk about provenance, we're not talking about some vague summary. The level of detail here is absolutely critical. You have to know the exact data sources, the precise timestamps for every event, every little transformation that happened, and even which version of the model was running with what configuration. Without that full picture, you just can't defend a decision.
But you might be wondering, okay, this makes sense, but why is this such a huge deal for AI specifically? It's because AI systems have this nasty habit of amplifying risk. They're not static files, they're dynamic, constantly learning and processing, and that changes the game. Here's the thing about AI systems. They're like a massive echo chamber for data errors. A tiny, almost unnoticeable mistake in one piece of data can get magnified and spread like wildfire through the system. Imagine a single bad sensor reading on a production line. That one little blip could lead to an entire batch of product being made incorrectly. That's the risk. Corrupted inputs will, without a doubt, produce misleading outputs.
So how do you manage that risk? Well, you build a system that looks something like this. You see 3 layers here. Down at the bottom, the execution plane is where the work happens. Your IT and your OT, or operational technology systems. But that plane is governed by a control plane above it, which is where policies and approvals are enforced. And the really crucial part is that everything, every single action, gets recorded in the evidence and audit plane. That's your unbroken, verifiable record of everything that happened.
Okay, that's the ideal setup, but let's flip the script. What happens when things go wrong? When there's an incident and an auditor shows up at your door asking questions? Let's walk through how an audit can completely fall apart.
There are 2 common traps that lead straight to a failed audit. The first is when you log what the system did, the output, but you have no idea why. You don't have the inputs or the context. The second trap is having all the data, but its story, its lineage, is broken. You can't connect the dots from the beginning to the end.
And in either of those cases, you've hit a brick wall. The investigation just stops cold. You can't explain what happened, which means you can't defend the AI's output. And if you can't do that, you can't trust the system. It's an instant failure. In the real world, that could mean you're unable to prove a medical device made the right call or a financial system followed the law.
Let's go back to our diagram for a second. Now you can see exactly where the breakdown happens. That evidence and audit plane is supposed to be that unbroken thread of proof. If your provenance is missing, that thread is cut. There is no way to trace an action in the execution plane back to the rules in the control plane. The whole thing falls apart.
Okay, so we've seen the problem. How do we actually fix it? This brings us to the most important part. How do we actually design systems that are built to be defended from day one? It's all about moving from principle into practice.
One of the first things you have to consider is just how much power you're giving the AI. If it's an assistive AI, one that just makes suggestions for a human to review, maybe you can get away with slightly looser requirements. But if it's an authoritative AI that's making decisions and taking actions on its own, it absolutely must have bulletproof, end-to-end traceability. It's simple. The more authority the AI has, the higher the burden of proof.
So how do you actually build that bulletproof traceability?
Well, it comes down to making some key architectural choices right from the start. These aren't just nice-to-haves, they are foundational. Things like using immutable storage so records can't be secretly changed, versioning your datasets so you know exactly what data the model was looking at, and using checksums to constantly verify that the data is clean. These are the building blocks for a defensible system.
Now, I just want to be super clear about something. What we're talking about here are the principles of data integrity and provenance. We are not telling you which tools to use or which specific architecture to build. Our goal is to give you the concepts you need to design trustworthy systems, no matter what tech stack you're using.
So I'll leave you with this one crucial question to ask of any AI system you're working with, especially in a regulated space. Can it explain its data? Because if an AI can't tell the complete story of its data from the very beginning to its final decision, then you simply can't trust it to act. Thanks for tuning in.